Alright, permutations and combinations. Just to let you know, this is going to be a little bit tricky. There is a subtle difference between the two. You got to look for some keywords. We will be going over those keywords tomorrow as well. But first of all, I want to talk about counting principle. What the counting principle says is if there are m ways to make a first selection and n ways to make a second selection, then there are m times n ways to make the two selections. Now, in language that you can probably understand, because I know that's a lot, basically that's saying if I have 5 scarves and 7 purses, how many different combinations can I make with them? Some of you guys have made lists before, and you found, well, hey, I only need to multiply those numbers, so guess what? There's 35 different combinations. That's the counting principle. A permutation is a little bit different. A permutation is an arrangement of objects in a specific order. Here for permutations, order matters. All right, that is the biggest thing. So, for example, 5 students are running for class office. How many different combinations of president and vice president could there possibly be? So, someone is going to be elected president, therefore they can't be vice president. That's the order. Order matters. Another example would be a horse race. All right, the horses coming in first place, second place, third place. Whenever there's places like that, there's a specific order. You're working with permutations. Now, the n factorial, or what you see, the n with the exclamation point, this has to do with permutations and combinations. What that factorial means, it's the product, so you're multiplying integers from n, whatever that number is, all the way down to 1. So, for example, if I have 5 factorial, what that actually means is 5 times 4 times 3 times 2 times 1. Take that number and you multiply every single number that's in between that number and 1. When you multiply it up, that'd be 120. So, for example, how many ways can 14 toddlers line up at the door? It would be 14 factorial, and that's when you would take, and no, we're not going to do this, but 14 times 13 times 12, all the way down to times 1. That is n factorial. Now, permutation notation is that lovely formula. All right, n factorial divided by n minus r factorial. What that means, n is the number of objects. Okay, so go back to the class officer example that I gave just 2 slides ago. There were 5 people running for class office. That would be the number. And then r is the number of arrangements allowed. Well, there's only 2 places, so your n in this example would be replaced with the number 5 people running, and r, the number allowed, well, there's only 2 places, so r would be replaced with the number 2. So what you would actually have with that formula is you would have 5 factorial all over 5 minus 2 factorial. So what that breaks down to, I'm going to move over here, 5 factorial all over 3 factorial. So break that down, 5 times 4 times 3 times 2 times 1 all over 3 times 2 times 1. Let me show you a quick little trick. These all eliminate each other. Basically you have 20 over 1 or 20 different arrangements, 20 different ways that could happen with the president and vice president. Now, a combination, the selection of objects where order does not matter. There's no places. So, for example, there's a group of 10 students. How many ways can they make a group of 7? They just need to break 7 of them off and go sit at a table. It doesn't matter where they sit at the table, it's just a group of 7. How many different groups can you make? So now, just like the permutation, combination has a certain notation formula, and it looks pretty much the same. The only thing that's being added is that r factorial in front of it. But again, your n is the number of objects. One second. And your r is the number chosen at a time. So same thing with the group example that I just gave. If I have 10 students and I'm choosing 7, every time I see the n, replace it with 10. Every time I see the r, replace it with 7. So we would have 10 factorial all over 7 factorial times 10 minus 7 factorial. All right, I'm just going to break that down a tiny, tiny, tiny bit for you. Now here's the thing, you got to do the factorials before you do the 7 times 3. All right. Good news, your calculator has the permutation and a combination button on there. Tomorrow in class I will go over that with you and show you how to use it, because our numbers are going to get quite large, to tell you the truth. We're going to get into the 20s, 30s, 40s, and that's nuts. If I would ask you to do, what's 40 times 39 times 38? So I'm going to show you how to use the calculator so you can solve these problems quickly. But again, there's a subtle difference. The permutation order does matter, and a combination order does not. So we're going to do a lot of problems with that tomorrow. We'll see you then.